Alright, good day everyone. This is the third class on differentiation, and we are going to continue from where we stopped in our last previous video. But before we commence, don't forget to like, subscribe, and also share these videos to those who are in need of it. Alright, so now let's continue. In our last class or our previous video, we talked about differentiation using second principle. Now for this, now we are also using second principle. What if now, well, like for this one, now we are going to be doing some other higher derivatives. Now the first one we have here is higher derivative. Now for example, let's say you have y equals to 5x square 4, 3x squared, 2x plus 5. And we have to find y prime. Y prime simple as dy dx. That's the first derivative. Are we clear? So from here, what do? We differentiate using second principle. We have, when you differentiate this one, this one will come down here. You have 4 times 5, 20, and subtract 1 from the power 3. Do you get it now? Plus this one comes down to multiply this as 2 times 3, give me 6, subtract 1 from the power 2 raised to power 1, and this one to differentiate, this one is raised to power 1. If I bring it to multiply it, that's 1 times 2, give me 2 times give me 2 raised to power, you have 1 here, subtract 1 from the power, that is 1 minus 1, that will give me 0, x raised to power 0, which will give me 1. You already know how to do our differentiation like this. Now if you have to differentiate again, let's say you have to find the second derivative, or you have to find the square y dx square, which is still the same thing as y prime prime. So how do you go about it? You are going to differentiate this one again. Now how do you differentiate again? Using second principle. That's 3, you multiply this as 3 times 20, give me 60, minus 1 from the subtract 1 from the power, you have 2, plus that 1 times this 6, you have 6, subtract 1 from the power. This one is raised to power 1. If I subtract 1, that's 1 minus 1, that's 0, that's x raised to power 0 here, and x raised to power 0 here will give me what? 1. That's why you have 96 here. And for this one, the differentiation of a constant is what? 0. Are we clear? Now let's find the third derivative of this same function. To find the third derivative of the function, which is d cube y over dx cube, what you do is that what you differentiate this one again the third time. Now differentiating this one again, you have what? 2 times 60, 120, subtract 1 from the power, you have all raised to power 1, and this one differential will be constant to give what? 0. Are we clear? So now let's continue from where we stop. Now the next subtopic we are going to be looking at is what? Chain rule. Now how do you solve question on chain rule, or how do you know that okay, this question I am to apply chain rule, or I'm to apply product rule, or I'm to apply quotient rule, or other forms of differentiation? How do you know that? Now we are going to start with chain rule today. Now we did some other subtopics in our previous lessons, but today we are going to start with chain rule. Now chain rule is simple as function of a function. Now for instance, when you have y equals to x plus 2 raised to power 2, now this is a function of another function, so automatically you are using what? Chain rule. Are we there now? This is a function of another, automatically you are using chain rule. Now but we can also use normal expansion for this, and also now use second principle for it, and then you still get the same answer as using what? Chain rule. Now let's follow this process. Now you have, if we have a case like, if you have a case like given y equals to this, and you have to find dy dx, and you know that for this one, for this function, you have y equals to x plus 2 square. Now this one can also be written as, this is a format whereby you don't want to use chain rule. Now this one can also be written as x plus 2 and x plus 2. If you expand, you have this. Are we clear? So from here now, that means y is equals to this, and it also equals to this, and also implies this. That means y is equals to this. Are we? So from here, when we differentiate, that means when we differentiate this one using second principle, we have what? 2x plus 4, and this differentiation of this one give me what? 0. Are we clear? So now this is because we can afford to expand it. Now I just the major reason I'm going through this is giving you an idea of what came about chain rule, why we use chain rule. Now let's look at it. Say this is because we can afford to expand it, but if we have y equals to x plus 1 is power 10, so it will be very difficult to expand something like this. On a normal setting, when you have a function y equals to this, okay, when we have a function y equals to this, and then you want to solve using differentiation, want to differentiate, you can still decide to expand this bracket easily. Since it's raised by 2, you can just divide to expand the bracket, and then now use your normal second principle to solve it. Are you getting it now? But in a case where you have raised to power 10, raised to power 20, you cannot start expanding raised to power 20, raised to power 30, and like that. And that is why we have to now introduce what we call our chain rule. In our previous class, we already discussed the formula for chain rule and all that. Now let's look at an example here. You have y equals to x plus 1 raised to power 10. If find dy dx. Now we have to find dy dx. Now we cannot use expansion method here whereby we expand, because in order to expand this, it will take you a lot of stress and time. So to save you of those stress, you just use chain rule. Now let's look at the solution. Now you have y is equals to x plus 1 raised to power 10. Now if you recall that the formula for chain rule is what? Dy dx equals to dy du times du dx. Take note, this u can be any symbol. You get now? It can be anything depending on what you want to use. I said in the last class. Now let's just use this for today. Now this is what you are given. So how do you go about it? What we do is that we say that let u be equals to what you have inside the bracket, that is u equals to x plus 1. Are you there now? Now if your u is equals to x plus 1, that means that we have to find, for us to find dy dx, we are looking for dy dx, we have to find dy du and then find du dx and then multiply them together to be able to solve your dy dx in terms of what? Chain rule. And how do you know that this is a chain rule? Because you have a function here of another function. Now, so that is why you are using chain rule. Now how do you now go about this? Now since you have said u is equals to what? X plus 1, then that means your du dx will be equals to, now du dx, why am I writing du dx? Because I'm differentiating u with respect to x. That's why it's du dx. So when I differentiate this one, I already said that let u be equals to whatever you have in the bracket, let it to be u. I get it now. So u equals to x plus 1. So that means your du dx will be equals to differentiation of this one will give me what? Differentiation of x will give me 1. You get it now. Differentiation will give me what? 0, using second principle. And now from here, now du dx equals to 1. Are we there? That means you have gotten du dx to be 1. Now let's define dy du. From this question, we know that y equals to what? This, and we already said that this one is what? Is equals to u. That means I can use it, I can replace this with u in my solution. That means I can say that u equals to y equals to u raised to power 10. Is it clear now? So if y equals to u raised to power 10, then differentiation of this one, that means dy du, because I'm differentiating y in respect to u, that means your dy du equals what? 10 u raised to power 9, because you'll be using second principle. This one come down, that's 10 subtract 1 from the power 9. Are we there now? Now since you have gotten dy du and I've gotten du dx, so now let's apply the chain rule formula. So applying chain rule formula, dy dx equals to dy du times what? Du dx, and your dy du is 10 u raised to power 9, and your du dx is what? 1. Right there now. So when you multiply them together, you have what? 10 u raised to power 9. Alright, so you have 10 u raised to power 9 times 1, and here you have, when you multiply them, 1 times this will still give us 10 u raised to power 9. This one still give us 10 u raised to power 9, and then we recall, if you have this one still equals to 10 u raised to power 9, and then we know that if you recall that u is equals to x plus 1, from our previous representation in this question, we said that u is equals to x plus 1. That means you can replace u to what? X plus 1. So when we replace u with x plus 1, you have 10 open bracket x plus 1 raised to power what? 9, and which will give us your final answer. Is it clear? So alright, so now using the short method. Now how do you use the short method? Now for short method, using the same question and giving this, how do you use short method? Instead of following that process of solving using the formula, we can use short method under chain rule. Now how do you use the short method? You have y equals to this. Now the first thing first is what? We differentiate the outside. We differentiate the what? We differentiate the outside. Now, how do we differentiate the outside? That means we differentiate the outside of this bracket. That is, we'll bring this one down, you subtract 1 from the power, just like you are doing second principle of differentiation. You bring this one down and you subtract 1 from the power. That means you bring 10 down, you subtract 1 from the power, just like as if you are doing, let's say you are doing 2x squared. No, normally this one will come down, and then that will be 4x raised power 1, subtract 1 from power. That's the same thing we are doing here. So you bring this one down, subtract 1 from power. So when this one comes down, you have what? So when you have this one comes down, you have 10. You write this one back, subtract 1 from the power, 9. Then now I'll differentiate the outside times. Now differentiate whatever you have inside the bracket. That is what differentiation of x will give me what? 1. Differentiation of 1 will give me what? 0. Do you get it now? So we have this. So when this 1 times 10 give me 10, I have this. So you see that, you can see that the answer we got here is the same as the answer we got when we used the long method. Let's use the short method for another example. So given that you're having y equals to x squared plus 5 raised to power 3, find y prime. You know y prime is equal to y dx. So if you have y prime equals, now to find y prime, we have what? Using the short method now, we differentiate the outside. How do we differentiate the outside? That is, you drop the power 3, subtract 1 from the power, that's 3 minus 1, that's 2. Then I write this back, you get now, times differentiate the inside. You have differentiation of this inside, that is differentiation of x will give me 2x, differentiation of 5 will give me 0. So you have 2x here. So that 2x will multiply 3, 2x times 3 will give me 6x, and we have this, and this will be your answer. You can confirm using the long method also. Another example using chain rule short method. Now let's say you have w equals to x raised to power 3 minus 3 raised to power 5. How do you do that? You drop the power. Now to find y prime, all you do is that differentiate the outside, you drop the power 5 and subtract 1 from the power, that's 4, and then you have this. To get it now, you get it, times differentiation of the inside. Now to differentiate the inside, you have differentiation of x raised to power 3 give me what? 3x squared, using what? Second principle. Differentiation of 3 will give me what? 1, and give me 0 rather. So we have 3x squared. So 3x squared times 5 will give me 15x squared, and then you have this should be raised to power 4, not 5. It should be raised to power 4. You get it now? So we have raised to power 4 there. So now you can also try these other ones on your own to see if you have gotten it using you can use both the short method and also the long method of what? Chain rule to solve this question. So I'll see you in the next video.